Okay. Good afternoon, everyone. This is Yandong from OPPO. Today, I will share some thoughts from OPPO about intelligent technologies used in mobile devices in the area of metaverse. At OPPO, we consider there are four supporting technologies for mobile devices in the trend of metaverse. One is environment perception, which helps your cell phone to understand the environment like human beings. Second part is the human interaction, which helps mobile device to interact with human beings. And third part is generation transmission, which means the mobile device should generate content and transmit the content with a very high efficiency. The third part is natural display. Nowadays, we use phones, large screen, and even AR or VR devices to present content and deliver good experience to users. In order to support these four technologies, there are computing platform and the service ecosystem. And this slide shows that the trend of sensor fusion and multimodal perception of cell phones. Years ago, phone used to make phone calls, of course, and later on, people leverage phone to take photos, and we call cell phone is a phone plus a huge camera. And these days, I think there are more and more perception sensors on phone, not only cameras or 5G modules. There are also IMU sensors, GNSS sensors, ToF sensors. If we consider IoT devices, there are phones, watches, and other mobile devices provide all kinds of perception models. And we need to leverage all these sensors to develop multimodal perception technology for phones. In order to understand the environment in a very efficient way, there are four steps. One is scene understanding. Second one is 3D point cloud generation. Third one is 3D reconstruction. And fourth one is localization, which helps you to understand where the phone or device is in the real environment. And I'll introduce very briefly OPPO's efforts in these areas. One is large-scale visual understanding based on knowledge graph. We develop a knowledge graph inside OPPO, and there are when we deploy this model across about 4 million mobile devices across the whole world, and these models are able to recognize from 10 to 1,000 to almost an infinite number of different types of tags with disambiguation, which is empowered by the knowledge graph. There are about 400 million users use this model to collect their photos in their phone album to understand the media content in their phone too. These are some of the papers behind these new features of our phone. I'll introduce one of the papers behind this feature, which is Vision Language Pre-training Alignment, published at ACM Multimedia 2022. And we leverage this technology to increase the text diversity over online multi-label recognition for vision language pre-training, which is very widely used these days to improve the vision recognition capability. And this is one of the pre-training technology used for segmentation. After we semantically understand the environment, we need to reconstruct the environment through mobile devices. And our technology has three major features. One is multi-device, second one is different scale, third one is cloud. We can reconstruct the environment on cloud and edge, and we have this cloud edge collaborating system to smartly adjust the calculation between edge and the cloud. And here is one of the paper behind this function. We call this view-guided point cloud completion. So the basic idea is that it happens that the LiDAR sensor will not produce very complete perception of the environment. For example, this is aircraft. The LiDAR can only perceive a part of the aircraft. This LiDAR is typically more expensive and less reliable compared with cameras. And we leverage the 2D image photo of the aircraft and do semantic understanding from the image. Then we leverage this information and develop a virtual 3D view of the aircraft and complete the aircraft as point cloud. I can show you here. This is the input, one of the input, the incomplete point cloud, and a single view 2D image. And we can get this enhanced point cloud, which is a very fundamental function to do 3D reconstruction from the world. Another part I would like to share with you is to do visual mapping and localization. One of the fundamental problem to for the mobile device is how to locate the mobile device in the real environment. Typically, people use point registration to do that, and we find out if we leverage the line features, the localization precision and recall can be improved a lot. And we published this paper this year too. Here is one very interesting example I would like to share with all the audience. So the actress here in this video, there is no makeup on her face, but based on OPPO's beautification algorithm or function, we can generate the makeup for the actress. Few people can tell it is generated rather than the real makeup. So the core technology behind this is feather weight model, which is a model super light and runs very fast. There are hundreds of or thousands of key points detected by the model, and based on this model, we can find out all the key points very accurately on the face and generate the makeup for the actress. And here is another example about how to understand the human being. Before this slide, I showed an example to understand the face, to reconstruct the face from the human. But here I showed them one example that how to reconstruct the body for the human, and we published this paper at CVPR this year. The key idea is that we find out the localized nerve of the human being, and by doing this, we can improve the precision, especially when people are wearing loose clothes on them. Another technology is to do 3D post estimation, and we combine this avatar modeling and the 3D post estimation together. We can generate this very interesting demo. Here we have this picture, and we have an animatable 3D reconstructible from for this model, and then we request the dancer to dance, and the AI can make the 3D model dance following the dancer. Another technology we think is very interesting for the metaverse is to do foreground mapping, especially when there are human object interaction in the image. We develop this virtual modality self-supervised technology to segment the foreground from the background very accurately. If we can see from the corner of these slides, it's very useful when you do background replacement for videos, movies. Another part I would like to show is super resolution. So the basic idea is that we can understand the environment, interact with humans, human being, and then improve the quality of the content. Last but not least, we need to display the content through some devices. One part is a screen with invent this 1 billion color display, which has 120 hertz intelligent dynamic frame rate, and can display 1 billion color, so people can have very good experience when people want to see the content on the mobile devices. Beyond that, we also introduced several generations of AR glasses. In 2020, we introduced the first AR glass, and in 2021, we introduced the second generation AR glass, which has a separate part, which is much lighter than the first generation, and we'll have more innovative AR glasses in the near future too. Another part I would like to show you is computing framework for mobile devices. One of the key technologies is that we can smartly find out which part of the calculation should happen on DSP rather than GPU, so that the calculation load of GPU to be reduced very dramatically. And if you can see here, the top video is generated or rendered by the GPU only strategy, and the bottom video is rendered by GPU plus DSP. As you can see, the rendering quality is much better. And based on all the technologies above, there are several interesting prototypes I would like to show. One is AR navigation. This part happens in Shenzhen, close to OPPO office. We do 3D reconstruction for 40,000 square meters of the entire mall, and we can provide AR navigation, entertainment, all this kind of augmented reality people can enjoy through either phone or AR glasses. If you walk through the hallway, you can see all the different phones, and here is a plaza. We generate a virtual aqua. There are whales and all kinds of different fishes in this plaza. People can easily find their car using this AR navigation technology. Not only this, we also deploy this technology on 4 feet robot. This robot can detect the human and keep following the girl in the video, who is also an employee from OPPO. This is right downstairs of our office in Shanghai. This dog can smartly recognize human and follow the lane right next to the river. You can see the real dog is also interested into the robotic dog too. It's fully autonomous driving. And talking about autonomous driving, we also deploy our technology on a real car too, which can recognize all different kinds of objects, reconstruct the environment, and have L4 level fully autonomous driving experience to all the users. And I think that's all for my today's presentation. Thanks a lot for hearing.